What's up, my fifth graders? Miss Hera Lambo here. Happy to see you. Today, we are done with all of our exact standards. So we are going to jump into review and remediate so that we can bomb, explode, blow up the PMA 3. So here we go. We're talking about a scientific method. So we're going to start with this video and then jump into the PowerPoint and discuss. I will be giving you an activity, so I want you to start thinking from today of something that you can do as an experiment. You do not have to complete the whole experiment, but if you're feeling like it, go for it. This is one of my favorite songs, and I did not get to share it with you guys this year, so I'm going to share it now. Scientific method, 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 scientific. First, you make an observation of the world around. Take notes and record all the things that you found. Then you ask a simple question, something that you want to learn. Then you form a hypothesis to explain what you observe. Then you make a prediction about how it's gonna go. To a test with a control and a variable. Then you analyze the data and draw a conclusion to the scientific method to avoid all confusion. Make an observation, ask a question, form a hypothesis, and make a prediction, do a test or experimentation. Analyze data and draw a conclusion. Make an observation, ask a question, form a hypothesis, and make a prediction, do a test or experimentation. Analyze data and draw a conclusion. Scientific method. 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 Scientific. First, you make an observation of the world around. So make an observation. If you're wondering something, why does this happen? What's going on here? That's what I want you to think of first. The next part, as we can see right here, take notes and record all the things that you have found. So when does this happen? What makes this happen? Take notes and record all the things that you found. Then you ask a simple question, something that you want to learn. How does the height of the ramp affect how far my car travels? How does the rain today affect the weather tomorrow? A simple question that you want to learn. How does the lights come on when I turn the switch up? Question, something that you want to learn. Then you form a hypothesis to explain what you observe. So I think the light will come on when I turn the switch on. I think if it rains today, then it will be cloudy tomorrow. A hypothesis is an educated guess as to what you think is going to happen. Explain what you observe, and you make a prediction about how it's gonna go to a test with a control. So then is the time to do the test. Once you think you know what's gonna happen, then you do the test. You have to have a control, something you keep the same. You're independent. One thing you change. If you change more than one thing, you're not doing the test right. And variables. Variables talking about my dependent variable is going to be my data. My independent is the one thing I change. Then you look at what you found out. You draw a conclusion. Boom. Here we go. Make an observation, ask a question, form a hypothesis and make a prediction, do a test or experimentation, analyze data and draw a conclusion, make an observation, ask a question, form a hypothesis and make a prediction, do a test or experimentation, data and draw a conclusion. question, form a hypothesis and make a prediction, do a test or experimentation, analyze data and draw a conclusion, make an observation, ask a question, form a hypothesis and make a prediction, do a test or experimentation, analyze data and draw a conclusion.
Scientific method. Scientific method. Clearly one of my favorite songs. It's just so catchy. And if you remember that song or even just the chorus of that song for your test, you can't get anything but 100%. Like it's all in that song. It's so simple. All right, guys, here we go. Nature of science. So science investigations. So this is SC.5.N.1.1. We have not talked about an N standard together. So this is exciting. N is standing for nature, things that naturally happen. So define a problem, use appropriate reference materials to support scientific understanding, plan and carry out scientific investigation of various types such as systematic observations, experiments requiring the identification of variables, collecting and organizing data, interpreting data in charts, tables, and graphics, analyze information, make prediction, and defend your conclusions. So here we go. Experiments. In an experiment, scientists control all the conditions. They study what happens to a group of samples that are all the same except for one difference. That one difference is our independent variable. Models. Scientists use models. This would be like me using, once again, here we go, an Earth model in the classroom to explain to you something about Earth. A model is just something smaller that is easier to be able to explain. I can't pick the Earth up and put it in my hand, so I will use a model. Repeated observations. You know, how many times do we repeat? Oh, observation, wrong thing. I apologize. I was getting too excited. Repeated observations. So I look at something, I watch it again, I watch it again, I watch it again. So I'm just looking to see if this is continuing to happen every single time. And a survey. A survey is a method for collecting information or data as reported by individuals. So scientists follow steps and use tools when investigating and answering or solving a problem. This process is called the scientific method. So you have your testable question, you do your research, you form a hypothesis, you gather your materials, and then you do the procedure. After the procedure, you collect and analyze that data, meaning you collect it and look over your data to realize what happened, and then you make your conclusion. So what is a testable question? We've talked about this very briefly. I'm going to kind of dig a little bit deeper into it. The question can be answered by an experiment and investigation. So that means you have to do an experiment or an investigation. The question allows for collection and analysis of quantitative or qualitative data. What that means, I cannot say, why is the sky blue, and say because it reflects off the ocean. That gives me no data whatsoever. I have to have quantitative data, meaning numbers. The water grew 1.4 meters. That's quantitative. You have to have numbers. Qualitative is talking about the quality of your data, talking about that the color changed blue to purple, talking about the way that the experiment changed and the smell that occurred. The third one, the question can be tested with age-appropriate supplies, materials, tools, and equipment. You would never want to do a science investigation on the moon. Why? Because unfortunately in 5th grade, you're never going to go to the moon, okay? So you have to have appropriate age materials. The question is not answered with a yes or a no. Do you like ice cream? Yes. Done. No, you can't answer the question with a yes or a no. If you can, you're not doing it right. Also, it cannot be explained by a book, or even better, it cannot be explained by Google or Siri. You cannot ask it a question and it give you an answer. Once again, that means you have no data. The question does not ask you to perform a skill. So you're not taking a basketball and shooting it 10 times to see how many times you make it. That is performing something. That is doing something. So can you identify a testable question? How will a large force and a small force affect the movement of an object? Is this a testable or non-testable question? Come on, tell me. Testable or non-testable? Yes, it is testable. How do you know? Let's look at the evidence. Can the question be answered by an investigation? Yes, you would have to take a large force and a small force. So I could do the same baseball, but using different things to hit the baseball. I can collect data. I can collect how far the ball actually travels. Being tested with appropriate tools? Absolutely. A fifth grader can use a baseball and bats. Is it answered with a yes or a no? No, you cannot say, how does a small force and a big force affect something? Yes. No, wait, no, that doesn't make sense. Are you performing a skill? No, you're doing something to collect data. Can you identify a testable question? The question is, what is motion? Is this testable or non-testable? Come on, tell me. Yes, it is not testable. If I went onto Google and typed in what is motion, it would literally pull up an answer for me. Motion is da 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 da. Boom. There's no data, there's no experiment. That is not a testable question. So here we go. We're going to go 1, 2, 3, 4, 5. I'm going to read them out loud. You're going to tell me if it's testable or not. When we come back and meet together, we'll discuss these in person. So is this question testable? Number 1, how does the mass of a ball affect the distance the ball travels? Is this testable or non-testable? Number 2, does a push make a ball roll across the floor? Testable or non-testable? Number 3, how does changing the diameter of a ball affect how fast it travels? Testable or non-testable? Number 4, why does friction slow down motion? And number 5, how do I measure distance? Good. So you should have had a 1 through 5 checklist. We will go over this together on Wednesday, but I will tell you this. You can also pause this video if you need more time right here on this slide. I will tell you that there are 2 testable questions and 3 non-testable questions. And we'll find out on Wednesday. Here we go. This is what I want you guys to do this week. So we'll talk about it more on Wednesday, but I'm going to put it here for you too, so that you guys can get into it. So I want you to create your own testable question. So this could be anything that you can think of. This is almost like a science fair project, but I'm not making you actually do the science fair project. This is just something I want us to talk about, because in 6th grade, you have to come up with testable questions and ideas very quickly. So I want you guys to be prepared. So once again, all I want you to do, I do not want you to create 3. I want you to create 1 testable question. Just one testable question. Make a hypothesis. Which surface, tile, carpet, or wood does a ping pong ball bounce the highest on? After a scientist has chosen a testable question, they need to make a hypothesis. So what do you think is going to happen? It is a statement that can be tested and explained. A hypothesis that is validated by evidence is considered to be correct. A hypothesis that is not validated or supported by evidence is considered to be incorrect and leads to more questions and investigations. When making a hypothesis, scientists will use their background knowledge and research to create their hypothesis for their testable question. So once you make your hypothesis, when you make a testable question, you will make a hypothesis. If, then, because. So what type of ball can be thrown the furthest? If I throw a baseball, football, and basketball, then the baseball will be thrown the furthest. So what type of liquid will help a plant grow the tallest? If I poured soda into a plant, 1, milk into plant 2, and Gatorade into plant 3, then Gatorade will make the plant grow the tallest. Guys, I am telling you, and girls, I'm telling you right now, you will need to do a science fair project for 6th grade. If you're doing this now, I can help you get that project done. So when it comes about, it's ready to be turned in. I know, I just blew your mind. I'm telling you guys, take this seriously and do it. You will need a science fair project for 6th, 7th, 8th, and 9th grade. So we're going to talk about making a hypothesis, so don't worry about this part. So here we go, variables. Variables is any factor that can change in an experiment. Your independent variable, one thing that changes. So I can only change one in one thing only. My dependent variable is going to be my data. Dependent data. So I have to have a chart or I have to have some numbers. Control group. This is something that I keep the same the entire time. If I'm only using a half a cup of water, guess what? I'm only going to continue using a half a cup of water. So here we go. I have my testable question. Which surface, tile, carpet, or wood does a ping pong ball bounce the highest on? My independent variable, the one thing I'm changing, are my different surfaces. My tile, carpet, or my wood. My dependent variable is going to be my data, how high the ball bounces. Then we make a materials list. Well, what did you use to do this, right? So if I was using the same testable question, I'd be using a tile, carpet, wood, a ping pong ball, a ruler, right? So I'm using materials every single time. That's all a materials list is. So procedures. This one is a little bit trickier. Procedures is a step-by-step process. Step-by-step. Meaning I can pick up your science fair, I can pick up your procedures list, and I could do your exact experiment. Exact. Meaning I don't have to guess. If I pick up your list and it says pour soda into cup, okay, what's my 2 questions? What type of soda? How much? Right? So it would say more so of pour Sprite into a cup measuring 1/2 cup. So, or I could say pour half a Sprite into a cup, right? So now you know exactly what you're doing. These are directions. Like I said, this is all going to be talked about on Friday. So I don't need you to actually do the experiment. But what I want you to do is I want you to have a testable question like here, and then your procedures to kind of tell me how you would do it. Like I just said too, you could have this done for 6th grade, guys. I'm giving you the opportunity to get ahead for next year. That's crazy to think about. I don't know why you wouldn't want to. You have all this time at home right now. Sorry, my screen got a little bit backed up, so give me just a second. I don't want to double click it. Here we go. All right. So data collecting. Before we conduct our experiment, let's talk about data collecting. You have to have a chart, a table, a graph, some type of journal, guys. We've already talked about this before. If you do not have data, you do not have an experiment. If you do not have a chart, you do not have an experiment. You have to have data. Have to. So now it's time to investigate. So now if you're going to actually do your experiment, then do it. If you're just going to talk about it and set it up for next year, that's fine too. So after we do our whole experiment, that's when we get into our conclusion. So what did we learn? What did our data show us? Did it match our hypothesis, or was our hypothesis wrong? And here's the thing that gets tricky. If your hypothesis was wrong, do you change your hypothesis? No. This was your thoughts. Your hypothesis can never be wrong. It is your opinion. If it is wrong, guess what? You learned something today, and that's the main goal. If your hypothesis was right, then you already had an inkling as to what was going to happen. That's it. There's no reason to change what your thought process was. So this is what we're going to do, guys. We're going to talk about our experiment on Friday, and we're going to go through the actual steps. You're going to make a testable question. You're going to form a hypothesis. You're going to gather a materials list. You're going to gather a procedures list. You're going to collect the data. You're going to talk about a conclusion. If you are actually doing the experiment, fantastic. Then this will be super easy for you. In the data part, so again, you guys did awesome. What I want you to go ahead and start is on, you can start it today, you can start it tomorrow, you can start it Wednesday, but it has to be done by Friday. I want you to have a testable question. I want you to pretend like you're doing a science fair project, but you do not. Don't tell your parents that you have to do a science fair experiment, because you do not. I want you to have a list. Okay, I want you to have a list going through that will be due on Friday. I love you guys. I'll see you later. Great job.